Hey everyone, we are looking at the derivatives of the other trigonometric functions. Now before we get started, our friendly calculus pig would like to remind you to use radians. We will always use radians in this class. Okay, so old news, we know already the derivative of sine x is cosine x and the derivative of cosine x is negative sine x. Nothing new there. But what about the other four? So let's build that. So say we're looking at secant x. If we just go to the definition of secant, we know secant is 1 over cosine. Okay, I don't really feel like quotient ruling that because I'm a little lazy. I'm going to rewrite this using an exponent. So I have cosine x in parentheses to the -1. I generally shy away from a -1 exponent because that makes people think of inverse cosine, but I really mean a -1 exponent there. So deriving this guy, we have derivative of the outside, so the -1 to the -2. Yes. Now we keep the inside the same, cosine x, and then times derivative of the inside. So derivative of cosine x is negative sine x. So rewriting this, I have y prime is, first of all, negative times negative, that's positive. And so I just have 1 over cosine squared x times sine x. I'm going to do a little weird borrowing, rearranging thing. Bear with me. So I have 1 over cosine x. I'm going to write bigger just so it's easier. Times sine x over cosine x. Do you see what I did there? Took my cosine squared x and just broke them up. It's like a bad divorce. So we're left with 1 over cosine x is secant x. And then sine x over cosine x we know is tangent x. So the derivative of secant x is secant x tangent x. You could do the proof for cosecant in much the same way. So going back to the box, derivative of secant x is secant x tangent x. One thing to watch out for when you're writing secant x, don't forget the c. You get something totally different. Okay, so for cosecant, I'm not going to go through the proof on it. You could go through the proof if you want because it looks just the way that we did it for secant. But the derivative of cosecant x is negative cosecant x cotangent x. So a memory device. First of all, one thing you're going to learn, we'll see this with cotangent in just a second, all the cos have negative derivatives. So it's pretty convenient. If it's a co, it has a negative derivative. But looking at trying to remember this, so secant x, the derivative is secant x tangent x. For cosecant, it's negative. We can just take our secant stuff and just throw cos in front of everything. Like instead of secant, it's cosecant. Instead of tangent, it's cotangent. So that's my memory device, is I kind of pair these guys in my head. Okay, let's take a look at the derivative of cotangent x. And I know you actually saw the derivative of tangent x in your last assignment. I was kind of sneaky like that. So I'm going to go with the definition of cotangent, which is cosine x over sine x. And then using my quotient rule, I have u is cosine x, u prime is negative sine x, v is sine x, v prime is cosine x. So our derivative here, I have u prime, so negative sine x, times v, which is sine x, minus u, which is cosine x, times v prime, which is cosine x. All of this over sine squared x because of v squared. Now cleaning this up, notice that I have sine squared x and a cosine squared x, and I have negatives in front of both. I'm going to rewrite this as negative, and then in parentheses, sine squared x plus cosine squared x. Since those were both negative, I could pull the negative to the front. And some of you are probably like, hey, I recognize that guy at the top. I know him. Yeah, I know him too. Sine squared x plus cosine squared x is 1. So we have negative 1 over sine squared x, which means we really have negative 1 over sine squared x is cosecant squared x. So our derivative of cotangent x, which is what we just did there, is negative cosecant squared x. And you found in the last assignment that the derivative of tangent x was secant squared x. And the same sort of memory device that we used on secant and cosecant works for tangent and cotangent. If you know the derivative of tangent x being secant squared x, which you can go through the proof like what we just did, but the derivative of cotangent, just throw a negative and a co in front of your derivative for secant. So now here's where things kind of get a little bit crazy. I don't know if crazy is the right word, but so while you're thinking about these 4 new rules, which you need to add those 4 to the list, you have to also be paying attention to every other rule you've learned before. Gosh, it's a lot of stuff. So for example, say we're looking at 4 cosecant to the 5th of 6x. This is going to get ugly. I'm going to warn you now. There's so much chain rule in here. First of all, I'm just going to rewrite this so I can see my inside versus outside a little more clearly. I'm going to write it as cosecant. I'm even going to put my 6x in parentheses just as an extra reminder. So notice that our inside has an inside. So that 5 is on the outside now. Okay. Y prime, we get the derivative of the outside, so 20 to the 4th. There's our derivative of the outside. While keeping the inside the same, cosecant 6x, times the derivative of the inside. So the derivative of cosecant is negative cosecant cotangent with insides the same, so times negative cosecant 6x, that stays in there, cotangent 6x. And now we do times the derivative of our inside, which is the derivative of that 6x, so it times 6. If you're feeling motivated, you can totally clean this up. There's not really need, but if it were a multiple choice question, you'd have to figure that out. Or if you just like being tidy because that's how you roll. So the 20, the 6, and the negative, we get negative 120. And then notice we have a cosecant 6x to the 4th times another cosecant 6x, so it's really cosecant to the 5th 6x times the cotangent 6x. So you really have to watch your chain rule carefully. And there's also going to be like your product rules, your quotient rules, and like all this other stuff while you are also trying to deal with these 4 new friends. And also remember, keep those radians going. So that is our derivatives of the other trig functions. You've seen the proofs for 2 of them. If you feel motivated, you could get the proofs for the other 2. I doubt anybody's that motivated. So keep on carrying on and happy calculusing.